So now we're doing solving linear inequalities in two variables without a technology. So we're doing this algebraically. The speed limit of a highway is 100 kilometers an hour. Cars breaking the speed limit. This means that the speed s, which car is traveling, is given by an inequality. It means you're going over 100 kilometers an hour. Okay, before studying linear inequalities in two variables, we'll review linear inequalities. So just remembering your signs is important. Okay, you read these in terms of their order. So it doesn't matter how you write it, but you read it the same way. So whenever the pointed side, that's your less than, okay, is left to right. So you got less than equal to, greater than equal to, and then just not equal to is the other one. Okay, so there's only 5. Okay, the following are examples of inequalities in single variable. So 4x minus 1 is greater than 7. 1 minus 2a is less than equal to 5. Now the important part here is that when we're solving for these, if we want to know what x is, we treat the inequalities as an equal sign. That's the main thing. So you just treat that as an equal sign and solve for the variable. So you still do stuff to both sides, it still works. The inequality doesn't change your equation format of how you treat it. Okay? So that's what we're going to be doing essentially today. We're going to be solving to figure out what the variable's inequality is. Okay? So let's go ahead and look at this example here. We have consider inequality 4 minus 2 times 3 plus x greater than 12. Solve algebraically. So we're just going to do what we normally would do. Okay, so we have 4 minus 2 times, this is being weird again, 3 plus x greater than 12. Okay, so the first thing I'm going to do is minus the 4. So I have negative 2, 3 plus x, come on, 3 plus x greater than 8. Now what would you do? I probably wouldn't distribute. You could. I would divide the negative 2 now. Okay? But when you divide the negative 2, what do you have to do with inequalities? You have to flip it, because you divide it by a negative. So it's going to be 3 plus x is now less than negative 4. And we're almost done. Minus the 3. Yes, it would work if you distributed. Yep. If you prefer that, that's fine. X less than negative 7 is your solution. Or multiply, yeah. If you divide or multiply a negative number to the other side, you have to flip the inequality. Okay, so check the solution using a test case. So what they mean by this is, what's a number less than negative 7? Nope.
Negative 8.
Negative 8, okay? So we're going to plug in negative 8 and see if it works. Okay, so we're going to go 4 times negative 2 times 3 plus negative 8 is greater than 12. All right, so let's look. 4 minus 3 plus 3 plus negative 8 is negative 5. What's negative 2 times negative 5? 10. So it's 4 plus 10. 14. Is that greater than 12? Yes. So we have the right solution set. Then it says graph the solution on a number line. So you don't have to do all the numbers. I'm pretty fine as long as you know, like we know the important number is what? Negative 7, right? So just put negative 7 in the middle. And then all you have to do correctly is it open or close dot? Open, because it's not equal to. Open dot when it's not equal to. Got that? So we go open dot. And then it's less than, so we go left or right? Left. That's all we need. Okay? If you have different color pencil or pen, you can go right on the line, but obviously it's hard to see. So I just go above it. Okay, yeah. So see how that's just less than? So less than and greater than are open dot. Less than equal to and greater than equal to, those are closed. Because you can be that spot, right? So if you can be that spot, you're going to fill it in. If you can't be that spot, you're going to open hole at that spot. Okay? All right, any other questions on that? Okay, not too bad. Okay, so, and Jared, what you just asked me is coming right here too, a little bit. Well, this is term of boundary lines. Okay, so the following are examples of linear equalities in two variables. So if you have two variables now, it's a graph, right? We're not solving for a variable, we're solving for a graph. That's people get confused. Like, how do I know I have a graph or not? Well, two variables versus one, right? We have y as a function of x. So the solution region of an inequality is represented by a boundary line. So what this means is, and I'm just going to draw a quick example for you. Okay, let's just say I have a graph that looks like this, a line. Just say 2x plus 1. And let's say it's equal to, so it's a solid line. And let's say it's greater than equal to. If I said greater than equal to, there's two regions, right? This line created two regions, up here and down here. If it's greater than equal to, where would you think you would shade? Right, above, left side, right? Because it's greater than. And so what that means, guys, is that all of these x and y coordinates make this true. Right? Like at the point -3, 8. That, if you plug it in, it'll make a true statement, just like we did with the 7. Okay? But with 2 points, okay, or 2 coordinates of an x and y. So we'll get to that, but I'm just getting to the point of what we're doing when you have two variables now. Two variables means you have locations. Okay? And so we're doing that in terms of shading. But that's just to show we got more coming here. So, like what Jared was saying, open dot, close dot, when you're doing lines, it's solid line or dashed line. So dashed line if it's not equal to, solid line if it is equal to. Okay, that's what this is saying. See, solid for equal to's, broken for not equal to, less than, greater than. All right, so let's see here. The following procedure can be used to graph the solution region for two variables. So it's nice to solve for y so you can see the slope, okay, for linears. So that's what they suggest. But let's just try a couple here. Y greater than x. It's already in linear form. Y greater than x, just in your mind, just think about it like this. It's just y equals x. That's just a slope of 1 right through, right? So it's greater than. So you're simply just going to do a dotted line like that. Just missed a little bit there.
Yeah, what the heck? Why is he so straight?
Just do it for a while, but then I messed up. You guys got too confident in me. Okay? Y equals x. And so now it says greater than. So then where would you shade? Right, up here. And so let me show you why this is kind of neat. Okay? Lucas, give me any point you can find in that red section. 2, 3. He's in there. Barely, but he's in there. Okay, 2, 3. So 2 for x, right? 3 for y. Is 3 greater than 2? Yes. So it works. Now if I said 5, -5. So 5 for x, -5 for y. Is -5 bigger than 5? No. So if you're not sure if you shade the right spot, just test the point in there and see. Okay? Shouldn't be any reason to get that wrong. Does that make sense?
Yes.
Yes. Good. Okay, for this one, we want to solve for y so we can see what we're graphing. We want to solve for y so we can see what we're graphing, okay? So we're going to do some work and solve for y. So we're going to -3x over. So we have -2y less than equal to -3x. I slide the -3x in front because I like my slope to be in front. Okay, if it's on the back side, it's not going to matter. But what do we have to do here? We have to divide by -2, which makes us flip the sign. So it's going to be y greater than equal to now 3 over 2x plus 3. Now we're ready to graph. I start at plus 3, up 3 over 2, down 3 left 2, down 3 left 2, and I have what I need here. Okay, is it solid or dotted? Solid. Okay, so there's your line. Greater than equal to, shade above or below? This is the answer region. Okay. What I like to test, what do you think is an easy thing to test all the time? 0, 0. Test 0, 0 every time. Okay, for this one, 0, 0 should have been what? Should be a not good, right? So if I put 0, 0 here, that's 0 minus 0. Is 0 less than -6? No, so that's the wrong, it's where it's supposed to be. It's not supposed to be a solution.
So you know which side is wrong?
Say it one more time.
No.
Nope. Okay.
How do you know like which area to shade?
So yeah, it gets a little tricky. Sometimes you gotta kind of visualize. What I kind of think about is just, I know sales is kind of tilted. I just think above it. Which section would you call above? And I just, for greater than, I always go above. Does that make sense? It's kind of hard because it's kind of sideways, but just think down here it's getting lower, right? So same thing here.
So for both of them, it's always above?
For these two, because they're both greater than. These two are both greater than. Less than and be below. Yeah. So like, where would you shade here? If I have this line, if I have a negative slope, where's above? It's over here. That's above now. Okay.
Do you ever get a question where it's like too wide and
We don't get into that, but yeah, I know what you're talking about. There's ones that surround you have boundary points, but yeah, that's for different stuff. Okay. All right. Graph the following inequality without using a graphing calculator. Okay, so let's try this one. 3/4 x plus 3, and it's less than. So we're up here at 3. 1, 2, 3 over 4. So this one's like right about there. Down 3 over 4, right about there. Is it dotted or solid? Thanks. Dotted. Dotted. Okay, and less than, above or below?
Below.
Okay, here's another one, Pearl, that I've told people before. If you're not sure where to shade, go find the Y-intercept and go below it or above it. That'll put you in the right region as well. Okay, so here's my Y-intercept, just go below. So I'm down here. So this time 0, 0 should work, right?
Yes.
Okay, so let's see if it works. So if I put 0 in, I got 0's less than 3. Is 0 less than 3? Yep.
Yes.
So we feel good about our solution set.
So this lesson is just shading stuff?
Yep. Your kind of lesson, huh?
Cool.
Sweet, man. Sweet. All right, one more example and we'll be done. Not bad for a 2-lesson day, huh? Okay. So the diagram shows the solution. So they gave us the solution shaded. Oh, I guess that's next lesson. But your calculator does this shading for you. I'll show you how to do that tomorrow or Monday. Yeah, it's pretty cool. Yeah, the diagram shows the solution region to an inequality. The boundary line has the intercept of -2, 0, and 0, 4. Determine the equation of the boundary line. So we're trying to figure out what this boundary line is. It gives me the x and y intercepts to do so. So what I need to do is that we just have to kind of simply, guys, you have 2 points. How do you find the slope? Rise over run. So it's y minus y over x minus x. Whoops, not x. 0 minus a -2 plus 2, 4 over 2. My slope is 2. So my slope of that line is 2. If you don't know what I just did, okay, it's math 9, maybe math 10. y2 minus y1 over x2 minus x1 gets you the slope, right? So you just subtract the y's over subtract the x's. Order doesn't matter as long as you go the same order, you'll still get the same answer. But by doing that, it's 2. I feel good about 2 because 2 is positive. Is this line positive?
Yep.
Okay, good. If I go up 2 over 1, it gets me to 4. So I do feel good about that. My y-intercept actually is this number right here, right? It's going through 4. So that's my b. So I'm good now. I know this equation is 2x plus 4. Now I just got to figure out what is the inequality.
It'd be less than.
Less than, and it's equal to because it's a solid line. If it doesn't give you 2, it's just what? Okay, so we kind of did all this stuff here, guys. So this is actually b. 2x plus 4 is the equation of the boundary line. Okay. So if we test 0, 0, because 0, 0 is in the shaded region, if I put 0 in, I get 0 is less than or equal to 4. That's true. We feel good about our what we wrote. Okay. All right, that's all for that.